Welcome to lecture on reservoir and dams, which is an important topic in water resources engineering. Reservoirs and dams play a major role in water storage, flood control, irrigation, and power generation. Reservoir A reservoir is an artificial lake formed by constructing a dam across a river to store water for irrigation, water supply, hydropower generation, flood control, and navigation. Reservoirs helps in managing water resources efficiently throughout the year. Based on purpose, reservoirs are classified into storage reservoir, flood control reservoir, and multi-purpose reservoir. Storage reservoir means store water for future work, and flood control reservoir is reduces the flood peak hours, and multi-purpose reservoir is used irrigation, power, water supply, and flood control. Based on location, the reservoir is classified into valley reservoir and upstream reservoir. Upstream reservoir constructed away from the river based on operator reservoirs are classified into conservation reservoir or distribution reservoir. The picture clearly shows that the aerial view of dam structure. Before constructing a reservoir, a detailed investigation are required. Topographical investigation include contour maps, catchment area and storage capacity. And geological investigation study rock type, stability, fault, cracks, permeability to ensure safety of the structure. And hydrological investigation involve rainfall data, runoff estimation, and flood frequency analysis. And meteorological investigation study evaporation losses, temperature, and wind conditions. And economic investigation include cost benefit analysis, land submergence, and rehabilitation uses. The next one is site selection for reservoir. A good reservoir site should have a narrow gorge with a wide upstream valley, strong foundation and minimum seepage and low seepage losses and adequate water yield. Then zones of storage in reservoir. A reservoir is divided into different zones of storage. The first one is dead storage. Dead storage is the water below the lowest outlet and is mainly used to store sediments. The second one, live or useful storage, is the water used for irrigation and power generation. And surcharge or flood storage is the temporary storage during floods to reduce flood peaks. Safe field of a reservoir. The definition for safe field of a reservoir is the maximum quantity of water that can be supplied from a reservoir during the critical dry period without failure. There are two types of safe field or farm yield and secondary yield. Farm yield means guaranteed water supply in all the days, and secondary yield is available in wet years. Then determination of reservoir capacity. The mass curve method is used to determine reservoir capacity. A mass curve is a plot of cumulative inflow versus time. By drawing a demand line, the maximum vertical distance between the mass curve and the demand line gives the required storage capacity of the reservoir. The reservoir sedimentation is accumulation of silt and sediments carried by river water in the reservoir. It reduces storage capacity, damages turbines, and shortens the life of the reservoir. Sedimentation can be controlled by catchment treatment, afforestation, silt ejectors, and flushing operations. Introduction to dams. A dam is a barrier constructed across a river to store water in a reservoir. Dam are essential components of water resources project. Types of dams based on material used. Dams are classified into earth dam, rockfill dam, concrete dam, and masonry dam. Earth dam means the dam is constructed using different earth material, and concrete dam is the dam is constructed for RCC, and masonry dam is constructed using stones. Then types of dam is structural action and purpose. Based on structural action, dams are classified as gravity dam, arch dam, and buttress dam. Based on purpose, the dam is classified into storage dam, diversion dam, and detention dam. Then structure of a dam, the main component is spillway. A spillway is a structure that safely passes excess flood water downstream. The common types of spillways are ogee, chute, side channel spillway, and shaft spillway. Spillways prevent overtopping and failure of dams. Then second one, ancillary work. Ancillary works include intake structures, outlet works, inspection galleries, energy dissipation structures, and drainage system. These components ensure safe and efficient functioning of the dam. The next one is selection of type of dam. The selection of dam type depends on valley shape, foundation conditions, availability of materials, height of dam, seismic conditions, and economic consideration. The different materials used for construction of dams, there is availability in nearby dams area. Examples, the selection of dam type depends on valley shape, foundation, and height of the dam. For example, narrow rocky gorge, that is a arch dam. The example of earth dam is wide valley, and gravity dam is constructed in strong foundation.